In this video, we're gonna think about multiple activity scenario. So in up to here, we thought about one-time interaction between injurer and the victim. So injurer is driving car once, and there could be an interaction in terms of accident with the victim, for example. But what if injurers engage in activities many times? So, for example, injurer may drive many times a day, so so there could be multiple accident with pedestrian. So, for example, injurer drove 5 times a day, so out of 5 times, there are 3 accident case, for example. So in here, we're gonna think about such possibility. So we're gonna think about multiple activity situation. So we're gonna define new terms. Z is a level of activity. So now Z represents level of activity. So if Z is bigger, it means injurer is engaging in activities many times. So for example, Z is equal to 3, it means injurer is driving 3 times a day. So then why does injurer engage in level of activity? Because it's gonna generate benefit. So we're gonna think about benefit function BZ. So BZ represents benefit from activity. So this is benefit. So benefit from activity. So with our driving example, if injurer drives car more often, he's gonna get more benefit, for example. So Z increases, then benefit goes up. So it implies derivative is positive. And we can also talk about second derivative. Suppose, so I'm gonna draw benefit function here. So x-axis is level of activity, y is benefit. Suppose I draw benefit function something like this. What does it mean? First, if you look at this benefit function, what is the slope? Slope is positive. So b prime is positive. And what's happening to the slope? As z goes up, what's happening to the slope? Slope is increasing. So slope is b prime, right? So b prime represents slope, and slope is increasing in this picture. So what does that mean about b double prime? So b double prime is positive. Slope is increasing. So something is increasing, so b double prime is positive in this case. So in this case, b double prime is positive. And what does that mean? So this picture says, so suppose Z is small. So your level of activity is very small. So for simple example, suppose Z is number of hamburger you eat. So for the moment, you are eating just one hamburger. So you are eating, few hamburger for the moment. So at this point, so you are having just one hamburger, and you get one more hamburger. What happens to your utility? Goes up, right? So you are still hungry, so you eat one more hamburger, your utility or benefit from eating hamburger goes up. And look here, now you are having already a lot of hamburger, At this point, you have one more hamburger. Then what's gonna happen to your utility or payoff or benefit? It goes up a lot? Maybe not. You already had enough? So one more hamburger maybe give you more happiness, but not that much, right? So we can think about this kind of situation here. So you drive a car, right? So you want to use car, and you want to use car often in a day, and currently you can use your car just once. And in that kind of situation, if you can use your car one more time, what's gonna happen to your utility? It's gonna go up a lot, right? But suppose you are using your car already a lot, so you are using car like 10 times a day already. In such a situation, you use your car one more time, what's gonna happen to your utility? Of course it's gonna go up, but it doesn't go up that much, right? So this kind of blue benefit curve doesn't seem to be realistic when we want to capture the benefit from your activity. So more realistic graph is something like this. So what does it mean? It means when your activity is small, additional activity gives you a lot of benefit. When your activity is a lot, additional activity increases your benefit but small amount. So this kind of graph seems more realistic, so we're gonna use this benefit function here. So in this case, we can see that, as you can see, what's happening to the slope. Slope is getting smaller. So b double prime is negative. And if b double prime is negative, we say original function is a concave function. So here we assume our benefit function is concave. And to make things simple, we're gonna consider unilateral care case. So unilateral care case. So accident depends only on injurious care. So accident depends only on injurious care. To make things simple, we think about unilateral care situation. Then first thing to do, we want to find the social optimum. We want to find the social optimum. So we want to maximize social welfare. So here, what is social welfare? Again, injurious utility plus victim's utility, right? And to maximize social welfare, now in this framework, we have to choose two things. First, level of care as before, and level of activity. So here we have to choose two things. How much injurer must be careful, and how often injurer can engage in activity. So we have to choose two things. So you follow the same process as before and write down injurer's utility and victim's utility and add them up. In the end, we get this social welfare. So this is our social welfare. So if you look at this social welfare function, look here, this term is familiar, right? So this is our social cost up to here. And now social cost part is multiplied by Z, level of activity. So up to here, we thought about just a one-time interaction between injured and victim. So it was enough to just care about this one-time social cost from one-time interaction. But now injured and victim interact many times. So we have to think about total social cost, and we can calculate this total social cost by multiplying level of activity. So this part, so this green part is social cost per activity. So you multiply Z, then you get total social cost. And look at this yellow part. This yellow part represents benefit or social benefit in our social welfare function. So this part is social benefit. So if something is positive in our social welfare function, it is social benefit, and if something is negative, it's gonna be social cost. So this yellow part is social benefit, and the rest is a social cost. And one thing to comment here is, look here. If you look at this social benefit part, it is BC. This is benefit from activity. And who obtains benefit from activity? It is injurer. So in this formulation, in our social welfare, social benefit is injurer's benefit from activity. So when we increase Z, so when Z goes up, so we allow injurer to engage in more activity, then it's gonna increase injurer's benefit. So it's gonna increase injurer's benefit, and it's gonna also increase social benefit because injurer's payoff is in social welfare. So something is good for injurer, then it is good for our society. So when we allow injurer to engage in activity more often, it's gonna increase injurer's benefit, so it's gonna increase social benefit. But at the same time, it's gonna increase victim's cost, because there is more accident on victim. So it's gonna increase victim's cost. So eventually, it's gonna increase social cost. So again, there is a trade-off going on here. So if you increase Z, so activity level is increasing. It's good in the sense that social benefit is increasing, but at the same time, it is bad in the sense social cost is also increasing. So what should we do? We have to find the perfect balance between these two effects. So our social problem is we want to maximize social welfare, and social welfare is this is our social welfare. So we want to find the Z and X to maximize social welfare. So if we solve this solution, it's gonna be X star and Z star. So see that both X and Z are chosen by injurer. So there is no room for victim here in this problem because we want to think about really simple setting in the beginning. So injurer has to choose X and Z, and it turns out that if injurer choose exactly equal to X star and Z star, social welfare is maximized. So, so look at this problem. How do we solve this problem? So take derivative with respect to z, then we get this and set it equal to 0, and take derivative with respect to x and set it equal to 0. So this first equation, and we have two equations. So we have two equations and two unknowns. So we solve these two equations, then we get solution x star and z star. So x star, z star must satisfy these two equations. And okay, so then look at the first equation. Move this term to the right hand side. Then we get so you move the term to the right hand side. So you move this blue term to the right hand side, then we get this equation. What is the meaning of this equation? It means this is marginal benefit. So this is marginal benefit from additional activity. So this is marginal benefit from additional activity. Why is it so? So this is B prime Z, right? So what is it? B prime Z, this is the slope of benefit function. So B prime Z means when Z goes up, then benefit goes up by this much, right? So B prime Z, loosely speaking, B prime Z measures the increase in benefit when Z goes up by 1. So this left hand side represents marginal benefit from additional activity. Then what is this right hand side? This is marginal cost. This is marginal cost from additional activity. Why is it so? So look here, in this social welfare, so look at this red term. What is it? This is total social cost. And look at this red term inside here. What is it? This is social cost per activity. So for each activity, this much social cost is gonna be spent. Therefore, right hand side can be interpreted as marginal cost from additional activity, because if we allow injurer to engage in activity one more time, then it's gonna increase social cost by this right hand side. And this equation says at social optimum, marginal benefit from additional activity must be equal to marginal cost from additional activity. So actually, the intuition behind this equation is same as MR is equal to MC. So from microeconomics, we know that if you want to maximize firm's profit, what is the rule? MR must be equal to MC. Marginal revenue must be equal to marginal cost. Why? So in your company, if you produce one more unit, what's good? It's gonna increase your revenue. How much? By marginal revenue MR. That's good. But if you produce one more unit in your factory, what's bad? By doing so, you have to spend more cost. By how much? Marginal cost MC. So at optimum, MR must be equal to MC. So intuition here is exactly the same. So you want to find the perfect balance and you want to find the best level of activity for our society. If you increase level of activity, it is good because it's gonna give more benefit to injurer. By how much? B prime. It's bad because it's gonna increase social cost. By how much? By this much. So if you want to find the best or optimal level of Z, this left hand side marginal benefit must be equal to right hand side marginal cost. And we're gonna think about the second equation in the previous page. So second equation in the previous page. So look at this blue equation. So you divide by minus g and move terms to the right hand side, then you get this equation. What does this equation tell you? The interpretation of this equation is exactly same as here in this equation. So this equation tells you how to find the optimal level of activity Z. Then this equation tells you what? This equation tells you how to find the optimal level of care X. So if you think about it, if you increase X, there's something good and something bad, right? What's bad? If you increase X by 1, what's bad? So you increase X by 1, so additional care, what's bad? Care cost goes up by 1. So this left hand side, number 1 represents that part. So you increase X by 1, so additional care gives you additional cost $1. So this is marginal cost from increasing X by 1. Then this right hand side must be marginal benefit from increasing X by additional unit. Why is it marginal benefit? So why is this right hand side marginal benefit? So if you increase X by additional units, so care goes up by 1. So injurer is careful by additional unit. Then what is good? The good news is it's gonna reduce what? Accident cost in our society. So it's gonna reduce accident cost in our society. So accident cost is this. So for each activity, this is accident cost and it goes down by how much? P prime x. Because you increase x by additional unit, then accident probability goes down by P prime x. So this is the change in accident cost when we increase level of care. So, and this minus sign is just to make the sign on both sides the same. So this right hand side indicates marginal benefit from additional care. So this equation tells you how do we find the optimal level of care. This equation must be true so that marginal cost from additional care is equal to marginal benefit from additional care.